Okay, so we're gonna do our a DC. We've got a DC shunt motor connected here, so we're using our standard DC motor. We've connected the armature conductors, or connection is direct to the variable source. It's running through this ammeter here, which is of course in series. Balance that up. This voltmeter will tell us when we're at 120 volts DC, which is what this motor operates at. Our shunt field is connected to the straight 120 volt DC supply. Comes in through our shunt field. Our series, our rheostat, which is on the front of this machine, is connected in series so we can vary the amount of field current. We're connected to a prony brake, which gives us a chance to put some additional load on this machine. And so what we're going to do is we're going to get this machine up and running with no load on it at 1800 RPMs, which is what it's rated for. We'll watch our armature current, and then as we add load, we'll see what happens to both the armature current for this machine as well as for the speed, as well as the speed. So first thing I'm going to do is energize the three-phase bridge rectifier. Our field ammeter is reading about 0.6 amps because it's straight 120 volts. So as we bring up our armature voltage, we're starting to build some speed. We're only running about 40 volts right now. See, we have very low current. Now, you'll notice every time I boost the voltage, the current comes up and then it drops back down to a low value. That's because when you first give more current to the armature, or more voltage to the armature, I should say, the current comes right up because there's not much resistance in that armature. The armature limits current based on the counter EMF that's produced in it as it rotates through this field. So when you give it extra voltage, the current comes way up and then it drops down as the counter EMF builds as the speed comes up. So I'm going to get this up to, now we're going to have to put some resistance in that shunt field so that we can keep our speed down. Put this up to 120 volts. And then we adjust our field rheostat. So we take resistance out of the field rheostat, increasing field current, which creates more counter EMF until we bring the speed down to 1800 RPM ish. Tough to get it exact, but you can see where we're at. So we're at 1798. That's with no load. As we increase the mechanical load on this, we're going to go up to 4 Newton meters. That motor didn't stop.